today by just talking about how to create a residual plot. So we're just going to go a little further into residuals. So we want to remember that to find a residual, that's your error amount. You want to do your observed y value, which is from the data, and take your predicted y value, which is from the model, and subtract them. So the first thing we want to do is we want to find a linear model for the data set below. So we have 5 x-coordinates and their corresponding y's. So we're going to go to our graphing calculators, and we're going to make sure that our lists have the right data in them. So I've already typed my data into L1 and L2. So then we are going to do a linear regression by going to Stat, go over right to the Calculate menu, and option 4 for linear regression. We're going to do L1, L2 for our x and y list, and we want to store our list by hitting the vars key, going to yvars, function, and then y1. Once we have all of that set up, we're going to hit calculate. So it comes out that our model is y equals 2.38x plus 5.5, and we have a correlation coefficient of 0.879. So that's a fairly strong, it's not super strong, but it's like between medium and strong positive relationship for this line. So we're going to go write that down. So our model was y equals 2.38x plus 5.5. So now we are going to use that model to find our residuals. So we are going to use our model to find all of our predicted values. So we're going to plug each x value in. So we have 2.38 times 1 plus 5.5. We're just going to use our calculators. So we could do this longhand like this and plug each one in, or we could be smart, and since we stored our regression equation in y1, so we can look there to check it, we can go over to table, and we want to make sure that our table set by going to second window is on ask, which mine is. So I'm going to go back to table, and then we're just going to type in the x coordinates. We're going to go 1, 2, 3, 4, and 5. And then we're just going to transpose our numbers over. So what we're going to get, to fill in our chart, we're going to get the 7.88, 10.26, 12.64, and 15.02, and last one is 17.4. So to find our residuals, all we're going to do is subtract across and then write down what it equals. So we're going to do 7 minus 7.88 and get negative 0.88. 13.2 minus 10.26 gives us 2.94. 10 minus 12.64, negative 2.64. 15 minus 15.02 is negative 0.02, and 18 minus 17.4 gives us 0.6. So now all we're going to do is to create a residual plot is we are going to plot all of the residuals we found. So I'm going to make a tally for each of our x-coordinates. So we have 1, 2, 3, 4, 5. And then our biggest residual is close to 3 on the positive side, so we'll go up 1, 2, 3. And then we'll just make it even. We'll go negative 1, negative 2, and negative 3. So when our x-coordinate is 1, our residual was negative 0.88. So it's like about here. For 2, it was up at 2.94, so really close to 3. For 3, it was down at negative 2.6. It's about there. For 4, it was really, really close, just on the negative side, 0.02. And then for 5, it's just a little bit more than half. So there's our residual plot. I'll show you in class next time how to make one of these on the calculator. But what we do, why we make residual plots is we want to look at what type of errors we're getting. Are we getting really big errors? Are our errors really small? What do we want? So the closer these points are, all of our residuals, to the x-axis, the better job our model is doing. So ours are pretty close. They're all within 3 units. They could be closer. It could be a better model, which we know because our correlation coefficient was only 0.87 or something like that. So this is like a decent model. It's not great. We also don't have a lot of data points to look at, but we're going to learn how to analyze these more in class next time.